All right, so the next thing is to take this CPU that is now pipelined and it's operating with this 3-cycle cadence to a machine that's, where possible, executing instructions back to back. Okay, so in that back-to-back scenario, we're going to look at both of these hazard situations and figure out better ways to deal with those so we can execute more instructions and get better performance. So we'll look at each one separately. First one we're going to tackle is the register file dependence. Okay, so what we're going to do is we're going to update the logic for this register file dependence to function in a situation where we have instructions back to back that are valid. We're going to make this update to our logic and still let everything operate every 3rd cycle. Just make sure we haven't broken anything. Then we'll address the other dependency, the branch target dependency, and then we'll actually switch over the valid so that we're actually executing the instructions more frequently. But first, to look at the register file dependence in isolation, now assuming that we do have back-to-back instructions. So the red dotted line here is indicating the issue that we currently have. So we're going to remove that path and introduce a better solution. So the situation we have is that we don't have time to write the register file in the previous instruction and read it in this instruction. And that's an issue only in the scenario where the previous instruction is writing a register that we then need to read in this instruction. Okay, this is a read after write hazard. So otherwise, the register file contains all the information that we need. We can, unless we're trying to read the actual register that was written by the previous instruction, we can just read the register file. All the other values are fine. So we keep that path reading the register file, and that path is a 2-cycle path, so that's the path all the way from this upper instruction down to the bottom. So we're going to connect it up that way. And then we're going to fix the scenario where we have this back-to-back read after write dependency. So if we look at that case now, the read after write, the previous instruction is writing a register that we happen to be reading in this instruction. And the value that it's writing is the result of that previous instruction. And the value that so the value that we need to read from the register, is that result of the ALU of the previous instruction. And we do have time, looking at the timing here, to bypass the value out of the previous instruction's ALU result into the ALU for this instruction. So we're going to create this path that bypasses the register file in the case where we're writing the register in the previous instruction that we need for this instruction. Okay, so this is called register bypass. And now we're going to look at adding these muxes and correcting this register file read path to not access the previous instruction, the register file state from the previous instruction, but the register file state from the instruction 2 cycles ago, 2 stages ago. So now to implement this, so looking at the logic no longer in waterfall form, so now we're seeing the logic from one instruction feeding back to subsequent instructions as these loopback paths. So the steps here, the first step is to make this path for the register file read based on the register file as written two instructions ago. Right, so now using this ahead by 2 operator, accessing the register file written 2 instructions ago. Second step is to introduce these muxes. So previously the source value are the two values coming out of the register file. You'll introduce a mux, and those values will now be the values coming out of the mux. You can add an intermediate signal for the one coming out of the register file if you like, or just make a big expression. So that value now, the source value feeding into the ALU, is going to take this bypass path where it's picking up the previous instruction's result, right? If the previous instruction's result was written to the register file, and the previous destination register, which is the index written to the register file, matches this source register's index, right? So if the value that we want to read from the register file is the one that was written by the previous instruction, then you want to select that. Otherwise, you can just use the result from the register file. All right. So this logic is, we're writing this to support back-to-back valid instructions. We're not yet going to enable back-to-back valid instructions. We're going to keep this 3-cycle cadence of valid. So this logic that you're adding should never be exercised. We should never be selecting the register bypass path, and it should have no impact on the behavior of your simulation. But you'll want to run simulation, make sure you still pass, make sure you haven't broken anything. And then we'll address the branch mispredict path, or branch path hazard. And then we'll update the valid logic, and at that point you can debug the register bypass logic as well. So go ahead and introduce this new logic, make the changes, and come back when you're done.